Okay, so this is a screen recording or a screencast of the homework for Mr. Forrest's AP Physics classes for projectiles. Hopefully I made fewer mistakes than the last time I did homework solutions, which I think were vector ones. At any rate, initially was due 10/28. This one was due 11/19. So we went on our 3-week tour of vectors between this. Okay, so first three we did in class. So basically the first three are all horizontally launched projectiles. The first one, you know the horizontal velocity, you know the vertical distance. So to find the time to fall, you've got to think vertically, and we use a version of delta x or delta y, so change in displacement is 1/2 at squared, and we can use that simplified version because there's no vertical velocity initially. So vertical and horizontal are independent. So we get 0.303 seconds to fall. We rearrange the only equation we have for linear motion that doesn't have acceleration in it, and we can figure out the horizontal velocity times time is equal to this distance that it travels horizontally. So it's about 7.9 meters. For PC22, we've got someone running off the edge of high dive, and he's going 4.6 meters per second, and you know the height here is 2.3 meters. So the first thing again is to find the time of falling. Do the same thing we did up above, 1/2 at squared. We get around 0.69 seconds. Always be careful to remember to actually take the square root after you put all those numbers in. The second thing was to figure out how far away he lands compared to where he launched, and that is the same as the first problem as well. So that's 3.15 meters. And then the last one is to figure out the total speed right before he hits. So the horizontal speed stays the same at 4.6. The vertical speed increases by 9.8 meters per second every second. And since we know the time that he's in the air, we know our final vertical velocity is 6.7. So then the actual speed, which is a vector resultant, is using Pythagorean theorem, 4.6 squared plus 6.7 squared, take the square root of that. And that's 8.1 meters per second. We could also have figured out the angle which he hits the water. I didn't ask that. For PC27, that's the third problem. Similar type of thing. You have something leaving with a known speed, 2.08 meters per second. It says that this thing hits the floor 0.963 meters away. So essentially now you need to think about the time that it's in the air and then figure out the vertical height here. So we're kind of working backwards. So to find the time to fall, actually this time we need horizontal information. And we know horizontal speed and horizontal distance. So we can rearrange that formula and get 0.463 seconds it was in the air. To think vertical and find out the height, we can use this general equation. We don't need an initial velocity because the initial vertical velocity is 0. So again, we come back to 1/2 at squared, and we get that this is a vertical height here of 1.05 meters. To go to the ones that are going to be due on November 19th, this is an angle launch projectile. So in this particular case, we've got sure and steady and always catching. Egg toss contest, and basically Sharon gave an underhand toss. It was this speed and this angle. So the first thing is to figure out the horizontal and vertical components. That's just using trigonometry. So sine and cosine, or cosine and sine respectively, to find horizontal and vertical. For the second part, to figure out the total time the egg is in the air, I want to split this up into parts, the first half and the second half of the trip. I will split this second half up. I'll think about that because it makes my life a little easier. So the vertical velocity up here is 0. The vertical velocity either at the beginning or the end is 4.03. So I take the time is equal to change in velocity over acceleration. And that's not a change in acceleration, so I might white that out. Yeah, you'll never know unless you look at this that I screwed up there. Ha. Okay, so looks like a little dot. Okay, so in this case then that's about 0.411 seconds to the top, or the time down. So either way, then we multiply by 2 to get our total time. Now, for the next thing, thinking about the horizontal distance the egg traveled, this is similar to the previous problems. We take our total time times the horizontal velocity, and we get the horizontal distance. So in this case, we only use the horizontal component multiplied by the total time, because that's how far it's moving horizontally. To calculate the maximum height that the egg reaches, that's where we've got to go back, and we think about this formula. So this would be the maximum height. And I like to think the second half of the trip, because we don't have an initial vertical velocity there. So we can think of the vertical velocity here being 0, and then we can think of finding the maximum height using that time only of the second half of the trip, because it's falling from the maximum height for only half the time. And so that should be 0.83 meters. So I did not label that either. I'm making all my corrections right here. That's fun. Okay, so PC29 was essentially looking at an angle launch projectile. So it's asking you to find the total time of flight, horizontal displacement, and the peak height. So basically the last 3 parts of this problem up here. So even though it didn't ask it, I'm going to get the horizontal and vertical components, and I'm going to find half the total time by using a version of this formula. Hey, there, I didn't screw it up. So I'll think of the time down, change in vertical velocity over acceleration. So that gives me 2.04 seconds. The total time is 4.08 seconds, because time up plus time down equals the total. And now to figure out the horizontal distance, I take the total time multiplied by the horizontal velocity, and then the max height, I think half the time, and I use my formula 1/2 AT squared. Oh, I forgot an A in there. Darn it. I am really screwing up with these things, but at least I'm noticing them this time. So I'll put that as a purple, and you'll never know. Yeah, you will. Maybe you will, maybe you won't. Okay, so I get 20.4 meters as the maximum height. This one I'll come back to. We'll definitely go over this in class. This one is a horizontally launched one. There's my picture of a drone. I hope you like it. But it's splitting it into a lot of parts. So essentially, the first questions are, what's the horizontal and vertical velocity right after the drone drops the package? 15 meters per second was given as horizontal. Vertically, it's not moving at all. Vertically, the instant it's dropped. What rate is the vertical speed changing? Well, that's 9.8 meters per second every second. The horizontal speed isn't changing at all. So then to figure out the time it's going to take to drop, if you know the drone is 60 meters above, again, we can rearrange this formula, solve for t, and that's about 3.5 seconds. So now, if you're in the air for 3.5 seconds, but the package is moving 15 meters per second horizontally, and if it's acting as a projectile where there's no air resistance, then we take that velocity times that time, and we get it that it moves 52 meters before it hits the ground. So essentially, this drone has to drop it. If it has a target on the ground, it has to drop it 52 meters before that. Letter F, at some point, then it's asking you, where is the drone when the package hits the ground relative to the package? So since the drone is moving horizontally at 15 meters per second, the package is moving horizontally 15 meters per second, the drone should be right above where the package lands when it hits the ground. So they both still have the same horizontal velocity, assuming, again, no air resistance. Okay. For this one, essentially you think you don't have enough information. So for 31, you have something launched at a 45-degree angle. It can span 98.3 meters. It lands at the same height where it was launched. So the key here, I think, is pretending to turn gravity off. So essentially, if this is launched at a 45-degree angle without gravity, it would go up 98.3 meters as when it's going sideways, 98.3 meters. Okay. So essentially, what gravity has done, if it lands at the same height as it's launched, gravity has pulled it down by 98.3 meters compared to where it would have been. So now I can think about this. I'm just showing you here how I figured out that 98.3 meters. You could use trig if you want, or you could recognize that 45-degree angle is equal sides. So now I'm saying, well, essentially this thing fell 98.3 meters compared to where it would have been. That lets me know that the time it's in the air is 4.48 seconds. If I know I'm in the air 4.48 seconds and my horizontal velocity is going to be constant, I can find my horizontal velocity by taking this 98.3 meters divided by 4.48, and that gets me a 21.95 meters per second horizontal velocity. And then, I'm trying to find essentially the launch velocity. The vertical would also be 21.95. So you could do this a couple different ways. I realize that the cosine of 45 degrees is equal to 21.95 over the launch. So essentially, I put V launch is equal to 21.95 over cos 45, rearrange it, algebra here. So that comes out to 31 meters per second. Again, there's a couple ways you could have done this last spot once you figured out the horizontal velocity. So that's tricky, but thinking about gravity off is sometimes a very useful thing to do from a comparison standpoint in terms of vectors. Thanks, and I hope these helped.